All right, so let's just take a look at a few of these questions. We're just going to do 1 through 5 here in this video from the factoring review for 3U. So we're going to write out the question here for x cubed plus x squared. When I look at something like that, not a whole lot to be done with the exception of maybe just common factoring. Okay, so by common factoring, we're looking for what's common or what's shared across the two terms. There's two terms there. And basically when we factor, we're removing things out. The thing that I can remove out is an x squared. So I'm going to get, and the other thing is when I remove things, we're dividing here. But if I were to remove it from the question altogether, we would change the question. So in order to counteract that division, we're going to write it out front in the form of multiplication, right? And then I can simplify x cubed and x squared, and x squared and x squared. So 4x cubed divided by x squared is just going to be 4x plus 1. That's going to be the answer there. Number 2. I have 144n squared minus 168 mn plus 49n squared. So with a question like this, it involves a little bit of recognition, but the clue that I'm particularly looking at is the fact that looks like something squared. And so when I have something that looks like this, I can square root the first and square root the last and take the sign that's on the b term. And so very quickly, we call this a perfect square trinomial. Okay, and so we can square root the first. We're going to get 12n, and then we're going to square root the last term. We're going to get 7n, and we take the sign from b, and we know that this thing has to be squared. That's it. And don't forget your equal signs. Okay, number 3. Number 3, we have 6x to the power of 4 minus 12x. Okay, again, not a whole lot to be done here without the just common factoring. Again, okay, so again, we're just looking at what's common across the two terms. What's different in this question to the first one is we have variables and coefficients in the common factor. So it looks like I can remove a 6x from both of these things, and when I remove it, I must write it out front. And when I divide 6x to the power of 4 by 6x, I'm going to get x cubed. And 12x divided by 6x is just going to be minus 2. Okay. Number 4. Okay, number 4 says we're going to get 9x to the power of 4 minus 16y squared. Okay, this little bit of, again, recognition, right? We're going to call this is a square and that's a square, and those two squares are separated with a subtraction sign. So we're going to see a difference of squares. Okay, and we have a procedure for difference of squares, which I'm not going to get into the logistics of why we do what we do, but nonetheless, you get to again square root the first, square root the last. But because we are missing, if you reference question 2, we are missing a middle term, which means the only way for that to have happened is if the signs are different in our two factors. So for instance, when I square root 9x to the 4, I'm going to get 3x squared. And when I square root 16y squared, I'm going to get 4y. What you're going to do with a difference of squares is you're going to write the thing twice. And the catch here is the only way, just referencing back what I said before, the only way to get the middle term to 0 pair out, that negative 168, would be as if this is a plus and that is a minus. And remember, when we factor, a way to check is to expand, which I can let you do. Okay, number 5, x squared plus 9x plus 20. Okay, this is what we call a simple trinomial. And we call it a simple trinomial because the coefficient in front of the x squared term is a 1. Okay. And so with a simple trinomial, we like simple trinomials because we have a simple process for factoring them. Simply what we're looking for is two numbers that multiply to 20 and add to 9. You can run through, you know 120, okay, that multiplies but never going to add to 9. 210 still never multiplies to 20, never going to add to 10. 3 doesn't go into 20, so you get to skip over it. 4 times 5. Oh, look at that. When I multiply 4 times 5, I satisfy the multiplication condition. And when I add 4 and 5 together, I get 9. So with simple trinomials, again, we like simple trinomials because as soon as I find these two factors, I get to write them on the right side of the variable. There's your final answer. And again, if you wanted to check that, you could expand it out, and you should always, because expansion is the opposite of factoring, you should always get your original question back after expanding.